use of refrigeration appliances often dramatically increase the energy consumption of mini-grid users due to the fact that conventional AC cooling devices are not designed for solar grids. This is leading to non-satisfaction of users and operators. The use of ice storage is an attractive option to reduce energy consumption overnight or days with low solar radiation. Cooling solutions able to balance solar energy fluctuations in communication with the mini-grid help to keep energy consumption under control. Let me explain you how our load shifting concept for mini-grids work. Ice is produced while energy is available. The cold energy stored in ice is used to satisfy cooling demand. Therefore, the cooling demand and electricity consumption remain independent from each other. This way, you can always decide how much energy you use from your batteries. Let's have a look to two examples, a cold room and a milk tank. Let us start with a cold room. In this case, we want to cool down a product to a certain temperature. We need to know the room volume and the mass of product to be cooled down per day, per week, or per month. The energy here is provided by an ice storage. This ice storage produces cold water that is circulated by a pump, going into a fan coil, a water-air heat exchanger that produces cold air whenever you need it. What about the milk tank? Here we need to know the tank volume, the milking times, and the storage time. Are you keeping your milk for 24 hours or perhaps for 48 hours? In this case, we also use an ice storage that produces cold water to keep your milk at 4 degrees. But how to combine and to connect the ice storages to the mini-grid? First of all, we need to know the energy availability, how many hours per day we can use energy from the mini-grid, and what is the maximum power that we can use. Once we know this, we combine it with a smart control. Let's have a look how this works. We can command the ice storage at 4 different modes. For example, at max power, when the solar radiation is high, or perhaps in efficiency mode, when the solar radiation is low but the batteries are still fully charged. We can command the ice storage also to an sleep mode or even stop it totally if you don't want to consume any energy. But how to command that? We can use a time switch to command the ice storage only during sunny hours. In a more advanced way, we can use the frequency of the grid. If you are using inverters, that command the grid frequency to be high when the batteries are fully charged and low when the batteries have a low SOC, then you can command the ice storage independence on the grid frequency. You always have also the option to have an input signal from the grid control to command the ice storage. This way you can always keep control on your battery state of charge. Let's design your smart cooling system. We need to know your cooling requirements and the energy availability of your mini-grid. Then we can commonly decide which optimal ice storage is suitable for your application. We are looking forward to hearing from you. Thank you very much for listening. Bye bye.